Hey guys, my name is Andres with student ID 0616110, and I'm just gonna go straight ahead and start talking about my screenshots for the project. So, the first screenshot shows the two virtual machines. So in this project, we'll be using the host machine to actually do the debugging, and we're gonna actually build the kernel and the modules and update our grub and everything on the target machine. And so then we'll send our updates from the host machine to the target machine. That's why we need two virtual machines. In the second screenshot, we're testing the serial connection between the target and the host machine. So as the host in the host machine, we are receiving this message from the target machine. So we're using the cat program, which is just going to output whatever content is in the file. And so from the target machine, we do echo, and then we echo it into the /dev/ttys1 on the target machine, and it'll show up on the host machine. And so that's what we're taking a screenshot of here. So for the third one, after we have our serial connection, we turn that off for a bit, and then we get to compiling the Linux kernel. So as a target machine, we use the wget command on the Ubuntu or on the kernel.org website, sorry, and we download the source code. So for this project, I use the 4.19.149 kernel, which is different than the example a bit, but the commands all still work the same. Oh, and by the way, I'm running the server version of Ubuntu just because I wanted to save some space on the install. But yeah, all the commands work exactly the same. So once we have the actual Linux kernel built, we have to patch it, or we have to change some of its configurations in the config file. So this is going to be, we're changing some of the things for our debugger. So on the left here, I'm showing the config frame pointer, which is going to help our debugger sort of look at pieces of code that are going to be left behind sometimes during the execution of the kernel. On the right-hand screenshot, we see the KGDB settings, and the KGDB is going to be our kernel debugger. And so when we set it to equal to yes, that means we're actually going to boot into a sort of a KGDB command line, so to speak, and that's what's going to allow us to debug our kernel. So we have to change some of the settings for the kernel debugger. For the next pair of screenshots, we are actually, well, on the left-hand screenshot, I had actually already compiled the kernel, but this is the command I use. It's the same command, just that I just took the screenshot afterwards. So it's a sudo make with the J option, and this $ and nproc in parentheses is going to run the nproc command, and it's going to sort of use the output of that as the last part of the command. So this part is going to it took about like 2 hours to compile. And then on the right-hand screenshot, we are actually going to be loading the kernel modules into the actual kernel. So the kernel is already compiled at this point, and we're going to just load the kernels into the already compiled Linux kernel. So after that, we have to do some final installations on the system, so that's why we run the sudo make install, and that's gonna take the compiled file, and that's gonna move it to its appropriate directory. It's gonna take care of all the rest of the things that really need to be taken care of for it to load up on boot. Okay, the next part, we have to update our grub, and so our grub is gonna be our bootloader, and it's gonna, you can see that on the left-hand screenshot, we run the sudo update grub, which is going to generate our configuration file. And so these lines where it says found Linux image, those are going to be the image files that we can boot into. And so we have more than one. Some of them are generic, and some of them are in case we need like to fall back on an older version on an older install if we mess something up. It's happened before by experience, so it's pretty painful. But now that we have our bootloader ready, we have to actually get the this VM Linux file in green, which is the actual bootable image file that we compiled on the target machine. But now we see it on the host machine, and that's because right above it we run the scp command, which is going to copy it using the SSH protocol from the target machine to the host machine. And so now we're actually ready to start debugging the kernel. So on the left-hand side, this is our host machine. And so what we're doing here is that we are running the GDB, which is the GNU debugger, on the VM Linux file that we copied in the previous screenshot. And so we are running it on the host machine. And so all our debugger commands are going to be run on the host machine, but since we're connected via serial port to the target machine, they're going to actually execute on the target machine. And so our target machine right now on the right is waiting for a remote connection from GDB. But on the left-hand side screenshot, we just entered the continue command in the GDB command prompt. And so what that's going to do, it's going to allow the target machine kernel to continue executing. And so that's going to take us to the actual Ubuntu Linux boot screen. When we type on the host machine continue on the debugger on the target machine, it's going to allow it to boot. And so that's sort of more or less what we did with the project. We got the bootable image file to the host machine, and then we ran the debugger on it and saw the changes take place on the target machine. So thank you very much for listening and for your attention, and thank you for the project. It was really helpful. Bye.